Alright, so we're going to be doing thermodynamics today. More specifically, we're doing specific heat formula, which is that equation right there, or that. They're the same, just different variants. Q is equal to the heat energy, M is equal to the mass, C is equal to the specific heat capacity of the substance, and delta T is the change in temperature. So to elaborate on Q, Q is the flow of heat. So if Q is positive, heat is being absorbed, and if heat is negative, heat is being released by the substance. And to elaborate on C, C is the amount of energy required to raise 1 gram of a substance by 1 degree Celsius. And here we have our problem. You are given a sample of metal and asked to determine specific heat. You weigh the sample and find that its weight is 54.8 newtons. You carefully add 2.70 times 10 to the fourth joules of heat energy to the sample and find that its temperature rises 18 degrees Celsius. So what is the sample specific heat? Well, you use this equation, you solve for C, you do a little algebra, and you should get this equation right here now. And then to solve for the rest of it, you get the weight that was given, right? 54.8 newtons. You solve for it using the equation right here. Weight is equal to mg. You do a little algebra, you get m is equal to weight over gravity, and you plug in the values, 9.8 meters per second squared for gravity, and you should get the mass is 5.5918 kilograms. And to solve for the change in temperature, the change was 18 degrees Celsius, which, since Celsius and Kelvin, the difference is in the same magnitude, it's also 18 Kelvin. And we're already given the flow of energy, so positive 2.70 times 10 to the fourth joules of heat. Then we use our values that we were given, that we have solved for too, that, and you plug into the formula. To this formula, you should get this right here, 2.70 times 10 to the fourth joules of heat over 5.5918 kilograms times 18 Kelvin. And our specific heat, our final answer should be 268.25 joules per kilogram Kelvin. That is our specific heat